Dolu falan yağdı ya. Direkt bizim şeyde. Babanın önünden gözüküyordu.
Hangisi yüksekti?
Of 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 of.
O 100 metreden fazla. Esas orada hortumun şeyini görüyor musun?
Hortumlamışlar.
Gökyüzüyle bağlantısını kaç yüz metre bağlantısını.
Abi şuraya bak.
Çatıyı uçurdu, gördün mü?
Of of of.
Baba çek, yakından çek, çatıyı uçurdu bak. Parçaları görüyor musun çatının? Zoom yapsana. Zoom yap. Bak çatı parçaları bunlar, görüyor musun? Bak şu an ekranda gözüküyor.
Dağıldık.
Çatıyı götürdü abi. Yakın. Zoom yap. Zoom. Parçaları gör. Hafif kaldır abi. Sağ olun. Gel abi.
That was some scary bad weather, wasn't it? Well, that is actually one of the lessons we are going to be going into today. So I wanted to start the lesson out with that just because it is crazy how weather can change so quickly. And we're going to talk about today some weather and climate and why things are like that. Did you happen to see in that video the two guys down by the boat running for cover? Oh my word, I would have been so scared. Now, the difference between the term weather and climate is the term weather is like this tornado. It is what is happening in the short term. Like, that was some crazy weather. The word climate is the average conditions over a long period of time. The global wind system is when heat from the sun moves across the Earth's surface. Air and water warmed by the sun are constantly moving. As a result, they make different areas of the Earth warmer and cooler. Hang on, I think Bill Nye has a video about that can explain it a little bit. Let's take a look.
Science guy. Bill Nye, the science guy. Bill Nye, the science guy.
Wind all over the world is caused by heating and cooling of the earth. The wind can do work. Hey, look at that. And it makes sailboats go! Wow, he went right through the door. Now, real wind doesn't come from a fan. No, in nature, wind is caused by the heat from the sun and the rotation of the earth. That's what makes these intricate patterns of clouds that we see on this photo from space. It works something like this. This is our great big plastic wind box of science. These lights represent the sun. This ice represents the north and south poles. So here's what happens. Energy from the sun heats the land, and the land warms the air over the land. The air molecules get going faster, and they spread farther apart, so they don't weigh as much for the room they take up. Cold air can push the warm air up. That's why we say warm air rises. So look what's happening. The smoke shows us that the air is sinking over the cold poles, flowing over the cities, and then rising over the warm parts. See, it goes around in a great big circle. And that's what happens on the Earth. Now, there's one more thing. The Earth is spinning, so the wind starts spinning. That's why wind comes from all different directions. Wind is wild.
Bill Nye, the science guy. Bill Nye, the science guy. Bill Nye.
So, from the warming and cooling, rotating and moving, winds are created. We call these prevailing winds, and they blow in across the earth at about every 30 degrees latitude. Latitude, you should know that word. Let's watch a video clip that explains each wind cell and where they fall in latitude on the Earth.
Have you ever wondered why we have different seasons depending on where you go during a certain time of the year? Or how about why we have certain wind currents? All these things have a lot to do with the way the Earth is shaped and how the sun hits it at a given time. First off, the sun's rays are responsible for heating up the planet. However, because of the Earth's curved surface, the sun rays don't hit everywhere equally. In places where rays hit at an angle, the distance covered might be greater, but the intensity of the light would be less. An easy way to understand this concept is if you took a flashlight and shone it down at a table. Straight down, you would get a different result than if you tilted it. Same goes for the Earth. Unequal light means unequal heating of the Earth. In addition, the Earth has a tilt of 23 degrees, giving us distinct seasons. For example, in June, the northern hemisphere is closer to the sun, which makes it peak summer. The southern hemisphere, however, is farther away from the sun, giving it colder climate. Now, it's important to make a distinction between climate and weather. Climate is the combined long-term effects of temperature and precipitation patterns. It's climate that determines the type of environmental conditions in an area, like whether it's a desert or a grassland. Weather is short-term conditions in a particular area, whether it's sunny or cloudy or rainy. While weather can be used to determine things like what outfit to wear on a certain day, long-term pattern, or climate, is what scientists study to measure climate change. Also, the amount of rainfall in an area determines its climate, which contributes to the type of vegetation that will grow there, and consequently, the biome. Now that we have an understanding of the difference between weather and climate, let's talk about precipitation and wind currents a little bit more, and how patterns vary across the planet. If we look at our planet, we see constant cycles of rising and falling air, which are created as a result of precipitation and temperature patterns in different latitudes. Let's start with the Hadley cell, which starts around 0 degrees and goes until 30 degrees. At the equator, the heat causes hot, humid air to rise. The evaporated water in the air falls back down as rain, making the air really dry. This hot, dry air then moves, cools, and falls back down at 30 degrees. The next cell, called the Ferrel cell, has cooled, dry air falling down at 30 degrees, which then sweep across the Earth and warm up. As it warms again, it rises around 60 degrees. The final cell, called the polar cell, has warmer air rising at 60 degrees. Similar to the Hadley cell, it starts to cool down as it travels sideways, before finally falling back down at the poles. To recap, wherever there is hot air rising, we generally have high precipitation. This translates to lower atmospheric pressure. You see vegetation-rich areas in places like this. Where there's cool air falling, the pressure is higher. Areas in these regions generally have less vegetation, like desert areas or the poles. Now, this isn't quite exact. There are a variety of other factors that also contribute, such as the Coriolis effect. But you can see how wind currents and precipitation, along with how the sun heats the Earth, contribute to the various diversity of biomes we have on our planet. So the next time you step outside, take a moment to appreciate all that goes on to making things the way they are. Thanks for watching. Want to learn more? Stay tuned for more videos.
So, now let's look at ocean currents and how they impact the weather. Like wind, ocean currents move heat around the Earth. The water's temperature affects air temperature near it. If the conditions are right, it can cause a hurricane.
Hurricanes are very large and intense storms. But where do these giant storms come from? A hurricane starts with the warm water found near the equator. Hurricanes typically only form in tropical regions where the ocean is at least 80 degrees Fahrenheit. These warm waters evaporate, creating warm, moist air which acts as fuel for the storm. Wind is also needed for a hurricane to form. Many hurricanes in the United States are caused by winds blowing across the Atlantic Ocean from Africa. This wind causes even more of the warm water to evaporate into the air. The warm, moist air then rises high into the atmosphere, where it begins to cool. Way up there, the water vapor condenses back into liquid water droplets. Water droplets in the atmosphere form clouds, including big, stormy cumulonimbus clouds. As the warm air continues rising upward, the winds begin blowing in a circular pattern around a center. The spiraling winds gather up a cluster of big thunderstorm clouds. Once the spinning winds reach 74 miles per hour, the storm has officially become a hurricane. Hurricanes are huge. They can be 10 miles high and over 1,000 miles across. Once a hurricane hits land, it runs out of warm, moist air and its winds begin to weaken. But the storm can still cause lots of damage to communities near the coast. Thankfully, we have weather satellites that are constantly monitoring the conditions down here on Earth. The GOES-R series of weather satellites scan the hemisphere every 10 minutes and the US every 5 minutes, keeping an eye on conditions that might cause a hurricane to form. Once a hurricane forms, the satellites can help predict the storm's intensity and track it minute by minute. This information allows meteorologists to deliver early warnings and help people stay safe. Find out more about Earth's weather at NOAA's site.
All right, let's go ahead and stop it there. And you should have a better understanding of weather through this lesson and through these video tutorials, and also the difference between climate and weather. The two extremes are tornadoes and hurricanes. And we look at the weather patterns in between the climate and the actual weather, the daily patterns, to be able to predict or be able to warn people about these upcoming disasters. Now, if you were to compare the two, which do you think would be more dangerous, a tornado or a hurricane? I personally would not want to be in either one. But let's listen to meteorologist Jason Myers and hear some facts. And then as you listen to the facts, I want you to make the call. Which one do you think would be more dangerous, a hurricane or a tornado?
A hurricane and a tornado. I'm Storm Team meteorologist Jason Myers, and they are both a testament to Mother Nature's fury. They both spin counterclockwise in the northern hemisphere, and they both cause loss of life and property each and every year, but they are far from the same thing. For one, they both form in very different ways. Hurricanes form in warm ocean waters. Moisture evaporates, rises, and begins to circulate. As the storm grows, winds continue to speed up, and eventually an eye forms around the middle. Tornadoes, on the other hand, spawn from thunderstorms. Rotation in different layers of the atmosphere within a thunderstorm create a funnel cloud that eventually reaches the ground. But neither one of these is necessarily more superior than the other. Difficult to compare, but something we can compare: size. Hurricanes can be hundreds of miles in diameter. The biggest tornado ever recorded had a damage path of a little more than 2.5 miles, but most are only 300 to 400 yards. In fact, tornadoes have been known to spawn inside a hurricane. Advantage: hurricane. Now round two. What about wind speed? Hurricanes may be bigger, but tornadoes still pack a punch for their size. Hurricane force winds range from 74 miles an hour for a weak storm all the way up to 157 miles an hour or more for a catastrophic Category 5. A weak tornado starts out with winds around 40 miles an hour, but an EF5 tornado has winds anywhere between 261 to 318 miles an hour, much stronger than the strongest hurricane force winds. Point goes to tornadoes. Tie ball game. Next round. What does more damage? Tornadoes do all their damage using those extremely strong rotating winds. Hurricanes, however, come with a triple threat. They use strong winds, heavy rains, and storm surge, bringing huge waves crashing on shore, causing more flooding. But even so, tornado and hurricane activity can vary from year to year, but study after study has shown that on average, they're both equally damaging and deadly. This one is a draw. But what lasts longer, has the endurance, the staying power, the stamina? Hurricanes last for a few hours to a few weeks, and the average falls somewhere in between. Tornadoes are on the ground anywhere between a few seconds to maybe a few hours for an especially strong storm, but the average is somewhere between 2 and 15 minutes. Hurricanes can go the distance. Tornadoes and hurricanes vary on warning time as well. Since hurricanes take so long to form and do a lot of traveling before reaching land, people usually have plenty of notice to take cover or evacuate. Watches are typically issued 2 days ahead of time, and warnings are issued 36 hours before anything happens. Tornadoes are completely different. Watches are sometimes issued an hour or two ahead of time, and the average warning time for a tornado is 13 minutes. Just enough time to get to a safe place. Tornadoes are definitely scarier for this reason alone. And now we've ended up with a tie, so it's settled. Don't mess with either of these storms. Thanks for watching. Don't forget to like, comment below, and subscribe to the channel.
Quiz time! Most of what you will be quizzed on in this lesson is from the videos, so make sure you watch them and listened. Now switch back to your agenda, click on the lesson quiz, and good luck!